Hello everyone. Today we will look at perspectives and views that are used in system modeling, and we will discuss how they are interrelated. System modeling helps to understand the system being developed, describing various system properties from different viewpoints. Consequently, we can say that system modeling is the process of developing abstract models of a system, and each model presents a different view or perspective of that system. It also has now come to mean representing a system using some kind of graphical notation. In many cases, the UML standard is used. It stands for Unified Modeling Language. System modeling helps to understand various aspects of the system, and models are used to communicate with colleagues, customers, and other stakeholders. Also, precise system models can be used to generate software. There are 4 widely known perspectives to describe the system being developed. These perspectives help stakeholders to understand different aspects of that system. In an external perspective, the model shows the context or environment of the system. In an interaction perspective, we model the interactions between the system and its environment, or interactions between the components of that system. In structural perspective, we model the structural organization of a system. In a behavioral perspective, we model the dynamic behavior of the system and how it responds to events. Views are the instances of the perspectives. A perspective can be described using several views. For example, the interaction perspective can be described using sequence and activity diagrams. These diagrams are part of the UML standard. Actually, there is no exact science or a way how views are mapped into perspectives. Also, I would like to stress that any modeling approach which allows describing the system effectively is a good one. Here you see a notorious 4+1 architectural view model. The 4+1 view model is not restricted to any notation, tool, or design method. The logical view shows the functionality and entities of the system. The process view deals with the dynamic aspects of the system. It shows how the system processes communicate and focuses on the runtime behavior of the system. The development view illustrates a system from developer's perspective. This view is also known as the implementation view. The physical view represents the system from a system engineer's point of view. It shows where the software components should be installed and what connections between the components should be maintained. Scenarios bind all these views. They describe how the system will be used by its end users. This picture shows how the UML is related to the 4+1 architectural view model. Logical view representation focuses on the decomposition of the functional services provided by the system. Their behavior can be represented using class diagrams, object diagrams, composite structure diagrams from the designer's perspective. The process view focuses on the runtime behavior of the system. Process view usually is represented using sequence diagrams, activity diagrams, state machine diagrams. Development view representation focuses on the description of system components from the developer's perspective at the design stage of the system. The development view can be represented using component or package diagrams. The physical view focuses on how system components are installed and connected within the physical devices. The physical view can be represented using deployment diagrams. Scenario or use case view focuses on explaining system functionality from the user's point of view. Scenarios are represented by using UML use case diagrams or agile user stories. Let's summarize this lecture. System modeling helps to understand various aspects of the system. Models are used to communicate with colleagues, customers, and/or stakeholders. It's a process of developing abstract models of the system. Each perspective can be described using several views. Views are the instances of the perspectives. There's no exact science on how to map views into perspectives, but the 4+1 architectural model can be a good guide on how it can be mapped effectively. Any modeling approach which allows describing the system effectively is a good one. Thank you for watching the Perspectives and Views lecture in System Modeling. Hope to see you in the next lecture.